Hello, brilliant minds across Nigeria. Welcome to the physics class. Are you tired of failing JAMB? Feeling confused by complex topics in physics, chemistry, biology, mathematics, or English? Well, breathe easy because help has arrived. Welcome to JAMB Masterclass series, where we break down the full JAMB syllabus, topic by topic, in clear, simple English with real JAMB past questions. Today we are going to fix where people usually fail. It's not just about studying, it's about studying with true understanding. So, grab your pen and notebook because from now on, success is no longer optional. It's guaranteed, inshallah. Here is how the structure will be. We'll pick a topic from the syllabus and teach it thoroughly and comprehensively. Then at the end, we'll select past JAMB questions related to that topic and solve them together. Today we are going to learn physics. In this first topic, we are going to discuss measurements. Under measurements, JAMB has listed 8 subtopics that you are expected to master. These topics are 1. Physical quantities. Which we have length, area, and volume, mass, units. 2. Units of the physical quantities. And how to relate them to their units. 3. Derived quantities. 4. Dimensions. 5. Significant figures and how to express measurements in standard form. 6. Measurement of distance, position, and displacement, so that we can break down all the tricks that JAMB uses when setting those questions. Now, what are physical quantities? A physical quantity What are physical quantities? A physical quantity is any property of a material or system that can be measured and expressed numerically using a standard unit. Property here means any visible characteristics of any material, like length, mass, color, etc. Why material? In science, if we say material, we mean any substance or matter that occupies space and has mass. It can be anything you can see, touch, or even feel, whether solid, liquid, or gas. Examples: wood, Examples: wood is a good example of a material because we use it to make furniture. Water, a liquid material. Iron, a metallic material. Air, a gas, but still a material. So, physical quantities are characteristics or attributes of things like length, mass, temperature. Length. Length is used to measure the distance between 2 points. For example, from this edge of this board to this edge. We use length to measure the distance of this board from this edge to this edge. While mass tells us the amount or quantity of matter contained in the body. Let us now dive into the classification of physical quantities. Physical quantities are broadly classified into two. One, base or fundamental quantities. Two, derived quantity. Let us now explain both the derived and fundamental quantities. One, base or fundamental quantities. Base or fundamental quantities. Base or fundamental quantities. These are the basic quantities upon which most quantities depend. If we say depend, we mean all other quantities depend on fundamental quantities to get their units. So either multiplying two or more fundamental quantities or dividing the fundamental quantities. Imagine the letters of English alphabet. A, B, C, D, all the way to Z. These letters may seem small and simple on their own, but they are the foundation of every word in English language. Words like physics, motion, or energy do not exist without letters. Whether short or long, simple or complex, every word is built by combining individual letters. These letters are independent, but all other words depend entirely on them. They are the fundamental building block of language. Likewise, in physics, we have certain fundamental quantities like length, mass, time, electric current, and temperature. They are the basic unit upon which all physical quantities depend. The second fundamental quantities we have is derived quantity. Derived quantities are physical quantities whose dimensions are usually from the fundamental quantities. Quantities like speed, acceleration, force, pressure, and energy are called derived quantities. The derived quantities are like words built from letters A, B, C, D, all the way to Z. Letters depend on words. Derived quantities depend on base or fundamental quantities. In this analogy, letters is like base quantities. Words formed from the letters are like the derived quantities. Just as letters form the backbone of all words, fundamental physical quantities form the backbone of all physical laws and measurements. Without them, no meaningful description of the physical world is possible. Every fundamental physical quantity is usually represented by a symbol, a shorthand letter that scientists everywhere can instantly recognize. These are not random. They are carefully chosen to provide a clarity and universality. Furthermore, to measure and express the magnitude of any physical quantity, it must be associated with a unit. A unit is a standardized quantity used as a reference for measuring and expressing the magnitude of a physical property. It is the scientific yardstick that allows us to compare, calculate, and communicate. Without a unit, numbers are meaningless. Saying the stick is 5 is as empty as saying I will meet you in 3, without specifying 3 minutes, 3 hours, or 3 days. Units inject life, meaning, and universality into numbers. Units are non-negotiable. Consider 2 examples. The stick is 5. This is nonsense. 5 what? Inches, feet, meters? It will produce a completely different stick. The second one, the cement bag weighs 50. 50 what? Kilograms, pounds, grams? The difference between 50 grams, the weight of a biscuit, and 50 kilograms, a full bag cement, is enormous. Units are the common language of science. When an engineer in Nigeria specifies 5 meters, an architect in China and a builder in Brazil know exactly what that means. This naturally prompts a fundamental question. Is there a single system of a standardized unit that is accepted worldwide to achieve global uniformity? Yes, absolutely. The system is called the International System of Units. SI units. The SI system defines the 7 base quantities of all fundamental physical quantities. With this foundation in place, we will now explore the 7 base quantities, their standardized symbol, and their corresponding SI units. Let us now dive deep into the nature, measurement, and philosophy of length. Length is more than a number, it's a dimension. In physics, length is one of the 7 base quantities of measurement, a fundamental building block of science. Many other physical quantities are created by combining length with other base quantities. Example, area is equals to length times length. Volume is equals to length times length times length. Speed is equals to length divided by time. Force is equals to mass times length divided by time squared. This shows that length is a dimension, a fundamental type of physical quantity that helps describe the size of an object, the distance between 2 points, and the shape of the space we live in. Definition and symbol. In physics, length is the measurement of the distance between 2 points in space. It is one of the fundamental physical quantities used to describe the size, extent, or distance of an object. Length is a scalar quantity. It has magnitude but no direction. Length represents distance between 2 points because it measures how far apart 2 points are. Examples: the length of a pencil. The distance between two towns. Size or extent of an object. Example 2. Height. How tall something is, ground to top. Wide. Width. How wide something is, side to side. Depth. How deep something is. These are all forms of linear dimension. A linear dimension is a measurement of length in a straight line. It tells us it tells us the size of an object along a single direction. So SI units for length. The SI unit of length is the meter. Symbol M.